Okay, number 16. So here we have a completing the square process all worked out, except that it's wrong. There's an error, and you are supposed to identify the first step where the error occurs. What I'm going to do is I'm going to work out the completing the square method over here on the right, and when my way gets different than this, that's where the error is going to be. So the first thing you do in completing the square is find the magic number and add it to both sides. So I need to take half of -8 and square it. Magic number is half of this number divided, half of that number squared. So that's going to be, -8 divided by 2 is -4 squared. -4 squared is 16. So I need to add a 16 here, and I have to add a 16 there. And we already see the mistake. 16 was not added over here. So B is where the mistake happens. All right, move on to the next problem if you're content. If you want to see the whole completing the square process, keep watching because it might be worth the review for you. So if you were going to finish this problem, you do factor the left-hand side. X times x works out to be -4 minus 4, and -15 plus 6 is 11. X minus 4 times x minus 4 is x minus 4 squared equals 11. Then you square root both sides. X minus 4 equals, what's the square root of 11? You can't do it, but you can or should put a plus minus in front of it. Now add 4 to both sides. X equals 4 plus or minus radical 11. So, oops, didn't mean to do that. So, come on. Oh, gosh darn. Okay, my Notability crashed. I have to close it and then open it back up again. Sorry about this. There it is. So this would be the final answer if you were to work it all the way out. But again, the mistake happened right here. Forgot to add 16 to both sides. That's why it's B. Does that mean that when you take the test, the error is going to be in answer B? It's going to be the exact same error? No, not necessarily. It could be, but it could also be that some other mistake was made somewhere. Add two numbers incorrectly, do a wrong square root, anything like that. Okay, number 17. Which equation matches the given graph? All right, this is extremely easy to do once you know the trick. It kind of goes back to the very first problem. Remember that the x-intercepts, -6 and -2 in this problem, those are the numbers that would solve the equation if it were set equal to 0. Well, if -4 and -6 make this equal to 0, then the question is, which of these equations can you, what, -4? I'm sorry, -2 and -6. Which of these equations can you plug -2 and -6 in to get 0? Well, if you look at the last one, if you plug in a -6, well, that's a stupid looking arrow, a -6 right here, or you plug in a -2 right there, you get -6 plus 6, which is 0, or you get -2 plus 2, which is 0. So the answer is D. So basically, whatever those zeros are, those x-intercepts, pick the terms with the opposite ones, and that's going to be your answer. So if you had a different, I'm getting a little off track here, but deal with it. If you get one where this is like +5 and this is -7, then the equation is going to be x plus 7, x minus 5, right? Opposite of this, +7, opposite of that, -5. So that's how that works. That's how the one on the test is going to work. Number 18. This is tricky. This was not taught directly to you in any of the lessons. This is kind of seeing if you understand some of the main points and how they tie together. So this graph shows a quadratic equation with what? Well, let's talk about discriminant. The word discriminant is in a couple of choices. So remember, if the discriminant is greater than 0, there are two real solutions. But a solution is the same thing as an x-intercept. So if the discriminant is greater than 0, that means there are two x-intercepts. Does this graph have two x-intercepts? No, it doesn't have any x-intercepts. This graph does not cross the x-axis anywhere. If the discriminant equals 0, there is one real solution. One real solution would mean the same thing as having one x-intercept. How can a graph have one x-intercept? It could come down and sort of just touch it once and then go back up. That's how you can have one x-intercept. But again, this graph doesn't do that. So the third scenario is the discriminant is less than 0, meaning it's negative. That's where there's two imaginary solutions. Imaginary numbers aren't real numbers. The x-axis is made up of real numbers, 1, 2, 3, -1, -2, -3. So the discriminant having two imaginary solutions means there is no real solution, or there are no x-intercepts. So this graph has no x-intercepts. That means it has a negative discriminant. So choice A is right? But also, no x-intercepts means there are no solutions. No solutions, no x-intercepts. That means that on this particular problem, D is the right answer, both A and B. The fact that there are no x-intercepts means that this discriminant is negative and there are no solutions. What are the other scenarios? Well, like I said, you could have one scenario where you have one x-intercept. One x-intercept would have a discriminant equal to 0 and would have one solution. That's not even choice here. And the third scenario is you get something like this, where there's two x-intercepts, so the discriminant would be positive. There'd be two solutions. So are you going to have exactly the same problem, number 18 on the test, as this problem on the practice test? Not likely. It's possible. It could happen, just to mess with you, but it's probably not. You know, we want to mix it up a little. So you might have the situation where there is one solution, or you might have a situation where there are two solutions. So that's all the information sort of summarized together that you need to know for number 18 on the test. Number 19. What is the conjugate? Quick and easy. The conjugate, and we covered this in a previous problem, you just change this middle sign to its opposite, and that's it. Nothing fancier, nothing deeper. The answer is just C. And number 20, simplify this. Okay, there's two things we're going to do to simplify this. First of all, the numerator, square root of 27, you can simplify into 3 times 9, which is 3 times 3. We have a pair of 3's, which is 3 squared, and then we have an extra 3. And remember that a square and a square root cancel each other out, so you can simplify out 1 3, but you cannot simplify out the other 3. It's going to stay in the radical. So this one is really 3 radical 3 over radical 2, but that's not one of the choices. The second part of this is that you're not supposed to have radicals on the bottom of fractions. How do you fix that? You multiply by square root of 2 over square root of 2. On the top, where you multiply, it becomes 3 radical 6. You multiply the radical part times the radical part. On the bottom, it becomes radical 4, or square root of 4, which is almost choice C, but not quite. You see we have square root of 4 right here. What is the square root of 4? Well, that's 2. 4 is a square number. Can you square root 6 or make a tree out of 6 to break that down any better? Nah. 6 is just, you can't do anything with it. So 3 square root of 6 over 2, which is kind of cut off here. Sorry about that, but that's going to be choice D. Okay, that is the last one. Good luck on the test.